Okay, Assalamualaikum and good afternoon. So, I think that I have mentioned that our class will be starting at 12 noon. So, if you look at to your timetable, it's actually begin at 10 o'clock, but I have something to do in the early morning, so we start late. It's okay. I just want to proceed to what we're going to have these sessions for 1 hour. And then, first of all, thank you for joining this course and also this class. I'm sure that if there are two elective courses offered to you, most of your friends select the other one, which is GIS. And you are in the course that I'm not sure why students are avoiding this course. Um, and I think that maybe some of the past stories by your seniors say that this course blah 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 blah. But I think that this one rely on you how you are planning for having this course for 14 weeks going smoothly, and how are you planning to have a good grade in this course subject. So don't be afraid since you are already registered here. Don't regret about it. Kalau kata you dah register dalam kursus ni pun, jangan menyesal. Kita carry on saja, kita proceed saja. So this is fated to you. You akan ambil this elective course, and I am very sure that this course is very benefited to you, very beneficial, because when you are doing final year project 1 for modeling and simulation, especially in the geotrend field area, so this course very helpful in order to give you a chance to hands on the Plexi software. So if you are doing your final year project 1 related to the modeling of the geotechnical applications or structure, so that is the best way for you to have the this course to be registered lah. Because I have seen a few students doing the final year project in Geotran on the simulations, but however unregistered for this course. So it is quite unlucky lah, because you have to hands-on for the preparations doing the final year project without any guidance, proper guidance. So without further ado, so let me share my screen for this morning sessions, what we're going to have and what's exactly my planning to share with you. First of all, on this topic. So it's not about the topic, it's a briefing how we're going to have our class so that you may not confuse. As you look at to your timetable, so the class will be at the locations Makmal ICT 1.5. If you are not familiar with that laboratory, you just go up to first floor from Laman Perdana area, and then there is a room Makmal 1.5. So for your information, I just want to tell you is that we're going to start off our lab hands-on sessions in the week 7 to 14. So for this time being, from week 1 to week 6, we're going to have online. I hope that every one of you are fine to have the online class, so that we just stay at where we are, so no need to walk to the Makmal ICT to have this lecture. Is it okay for you, everyone? And I'm sorry to forget to introduce myself. And I am Ashita Manujit. I will be conducting this course for Group B. So I hope that in the future we're going to have a sessions so that you can introduce yourself. However, for this 1 hour lecture, I am very sorry because I am very limited of time. So let me take over all this class by giving you briefing on this topic and also how we're going to execute this course. So as you can see on the first one, as I said, this course will be conducted through the hybrid sessions learning. Face-to-face will be on week 7 to 14. Meantime, from week 1 to week 6, we're going to have online sessions. So as you can see here is that the attendance is very important. For this semester, I'm going to take directly the attendance of the student joining this class from the Microsoft Teams attendance participant list, so that you don't have to go to your future to sign in and also to tick or to click the attendance or the presence of yourself in the lecture class. So that will be much easier compared to previous semester. When I ask the student will say that they forgot to click or to tick the attendance. So that you just join the class, that will be fine for me. So that I believe you are attending my online, even though I am not sure what you are doing behind your laptop or behind your camera. And then if you look at this course, it's actually quite tough because this is an elective course and it's consumed around 2 hours lecture. However, there will be lesser than 2 hours. Remaining 1 hour will be on your off time, where you can have your personal learning on this topic. I will be giving you a tutorial on this each topic that we attended every week. So you can have from the your future by joining the course from the youth future specific for the group, and click for the learning activities. So you need to participate every week for offline sessions, that showing to me you are present in the one remaining hour. So I hope that you can fulfill these compulsory conditions lah. Sebab kalau ikutkan our course having a 3 hours lecture, but then I only take around 2 hours to give you a lecture. So remaining 1 hour, I leave it for you to have your personal learning on doing the learning activities. Okay, this is one example how I am tracking the attendance. As I said last semester, I used the youth future for online class. Having this section, you need to tick your presence of these sessions online. And then this is some example. Once you tick your presence, then I will verify lah your presence in the online sessions. So this is for online class. And similar to here, this is I obtained from the Microsoft Teams attendance report. So this is directly after we finish the sessions, so I can see who joined, who left less than 30 minutes or left after 1 hour. So I can see from here. And this is another one which I said just now, is on the offline class, where I assign a tracking report as an official for every student to participate and answer the exercise. How do I know that you are already joined the learning activity sessions during the offline 1 hour? I will be using a tracking function there in the future, and I can record, I can trace that is it you are fulfilling the condition 1 hour or not, because this is the easiest way for lecturers to track all your presentness. So this is one example that I showed to you here, yang mana kalau untuk 1 jam tu selalunya I try to give the simplest or the less number of questions that you can answer. Some of the question may take directly from the lecture notes ataupun from the past year questions. So this is the summary of what we're going to have in this 14 weeks. For example, plus minus 1 hour preparation for revisions, and then plus 1 minus 1 hour answers, which I allow you to have the learning activities within 7 days. So kalau kata kita mula hari ni Monday, so I will be close the sessions to the next Monday. So maknanya you ada masa free lah, flexibility for you to complete the learning activities. So saya tak katalah, kalau kata baki 1 jam kelas kita sepatutnya hari ni pukul 1-2 contohnya, ataupun pukul 12-1. So you kena buat dalam tempoh tu. Tak. So I give it you your time, your personal time management when you are planning to do your learning activities. So you ada masa lah untuk aturkan, jadi you buat dalam tempoh 7 hari tu. Kemudian you have 1 hour to review and check your answer. So this is one example how I track the record of the learning activities. So this is similar answers, a report, tracking report for each particular week that I assign to the students. So on the previous semester, the problem due to student couldn't join the youth future. I'm not sure what was the problem. Maybe due to the group registered. So I hope that you are not having a problem during the registration. So because it's very important week pertama, week 2, week ketiga ni, sebabnya later on the lesson plan you will see that when are we going to have our first assessment for this course. Again, this is a summary where you can have that actually I am using few platforms to deliver the teaching and learning. For example, online, I'm going to use the Microsoft Team. Kemudian for attendance and also for the learning activities, it can come from Microsoft Team as well. Also YouFuture. And content or notes you can download from the YouFuture under folder CEG612. And for the evaluations, I think that for this semester there will be face-to-face punya assessments test lah. I mean that you have to come to the specific room to answer or to sit for the test one, similarly to the final assessment ataupun final assignment. So just to inform you early supaya you lebih bersedia lah. Okay, what is the differences? What are differences between online class and also offline class? So these are some guidelines that you may follow. For example, do a preparation revisions on weekly topic and note taking before class starts, and then do peer discussion and prepare a response to a task given, formative assessment or quiz, and the next one, try to answer questions and try to answer the question given to you, and the answer will be uploaded a week later lah. Maknanya kalau kata hari ni saya start assign you buat exercise for week 1, so after next Monday I will uploaded the answer for the past questions that I uploaded last week. So that's I mean here. How about the offline class? So you need to have a personal or individual, what we call it, notes, for example, or if you have anything to ask, you may ask through the Telegram. For this semester, we're going to use a Telegram for communications. So WhatsApp ni dah tak ada. And then do some peer review article from easy access online database, and be creative and innovative in summarizations, weekly learning outcomes in mind mapping, and submit on the platform specified, for example, YouFuture, or watch a recorded video, YouTube, do past year final exam questions. These are some guidelines that you may follow, but it's up to you because you are already part 7. I believe you are already in the final year students, so you more matured compared to the junior students in the year 1, year 2 and also year 3. So I hope that you can prepare well as well as in your personal time ataupun learning time. So kita tak nak nanti ada masalah lah, you tak boleh nak commit kan. Sebab khusus ni lebih kurang 3 kredit jugalah. Okay, yang ni very common. So later on we explain on the OBE. It's very important as your finance students, as also engineering students, to know what is the OBE, what are the domains that covered in our course, and then what you may expect from this course, from the learning outcome or from the program outcome or from the weekly outcome. Okay, this is for example learning lesson plan for this subject. So we begin to start chapter 1 in the week 1 until week 3. So it's on the stress strain, and then what are the stresses, how the soil respond under loading, for example, and then in the week 4, 5, so this is in chapter 2, and we're going to have a break. Before that, in the week 5, you may have a first assessment, which is a common test that covered from the topic 1 and topic 2, excluded more color model. So our tentative date for this common test will be on 27 April 2022, 8 hingga 10 malam. Apa pentingnya saya announce this one because saya tak nak nanti in the next 2 or 3 weeks you mention pada saya or you tell me that we have another test that clash on this subject. I'm sure that every week on the week first, all courses that you registered, try to say or try to share the lesson plan. So you can jot down, you can note down all the important dates here, and then you inform earlier about the clash date or any dates yang you rasa you tak boleh nak commit, all of you tak boleh nak commit, for example. And don't tell at the last minute yang mana kita pun nak buat anjakan pun tak boleh, because we are following to the UiTM punya guidelines where you need to have first assessment in the first 1 to 5 weeks. Maknanya nanti you balik cuti tu, kepala you kosong dengan benda-benda yang berkaitan dengan kursus ataupun persediaan untuk test selepas cuti semester, for example. That's the planning why we are doing our test in the week 5. Kemudian lepas you naik midterm break, kita akan ada satu lagi remaining week untuk chapter 2. So this is on the returning wall. But this time, returning wall kalau you tengok kat sini, dia akan menggunakan conventional analysis or the what we call it the cara biasalah kita analyse returning wall punya active pressure, passive pressure dan juga dia punya forces. But then you may see later on all the applications Eurocode in the geotechnical design. Okay, back to week 7, kita akan jumpa semula chapter 1 yang mana sebenarnya chapter 1 will consume around 4 weeks, tapi sebabkan we want to have that the connections, how the important more column model in geotechnical modeling, so we put it together close to the chapter 4. So the chapter 4 is on about geotechnical modeling using numerical approach. So it means that here you may use a software or you are having a open source online software to make you easier to do the modeling and simulation. But don't afraid, if you feel that you couldn't have or you don't have what we call it, you don't know how to access to this online link or the open source of the numerical software, you can come forward to our lab Makmal ICT 1.5 in the blok perdana untuk you buat you punya modeling and simulations specifically on the plexis lah. We talking about plexis kat sini. Kemudian dia akan consume selama 4 minggu daripada week 8, 9, 10, 11. Okay, kemudian week 12 hingga week 14, this is the applications of the Eurocode 7 in geotechnical design, where at this particular weeks you akan nampak macam mana kita nak design returning wall, how are we going to design foundation, shallow and deep foundation using the Eurocode standard. Yang mana sebelum ni kalau you tengok chapter 2, mungkin kita design returning wall menggunakan gross method, British standard method. But this time untuk 3 minggu terakhir kita akan belajar macam mana kita nak design geotechnical application menggunakan Eurocode 7. So as you can see in the blue color font here where the tentative for quiz, yang mana dia akan cover chapter 4, kemudian project. So apa yang saya mention ni adalah beberapa assessments lah dalam awak punya khusus ni lah. Contohnya kita ada common test 1, kemudian kita ada quiz, kemudian kita ada project, lastly kita akan ada final assignment. Ada setengah khusus dia panggil sebagai test 2 lah kat sini. So nampak ada 4 kan. All those assessments bring to you 100% cumulative dia punya markah. So that's all for what we call it here lesson plan. So penting ya saya share dengan awak lesson plan. Kemudian okay, a little bit on the OBE. Mana OBE? Okay, OBE ni asalnya saya dah share satu PDF OBE kan. And then kalau you tengok kat sini pun saya dah attach also the QR code for OBE. So I think that you need to have your personal time lah untuk review what is on OBE lah. Contohnya kalau kata CO1, PO2, PO2 ni apa, PO3 ni apa. So I hope that you are familiar lah. Okay, PO2, PO3 ni siapa boleh jawab? Kita nak refresh sikit lah pasal OBE. Siapa boleh jawab PO2, PO3 pasal apa? PO2 pasal apa? PO3 pasal apa? Sebab you nak jawab soalan nanti kan, common test, you nak jawab project. So you kena tahulah apa dia PO1, PO2 dan juga PO3. Okay, saya rasa grup ni kalau ikutkan berapa orang kita semua? Okay, lebih kurang lah. Okay, never mind lah. I think that PO2, PO3 dia lebih kepada design dan analisis. Kemudian PO2 ni lebih kepada what we call it here is on okay, PO2 lebih kepada PO2 problem analysis, PO3 design untuk dapatkan solution kepada problem yang kita ada. Okay, now we go to the first overview on the topic untuk chapter ni. So saya akan pergi kepada okay, this one. Okay, sebelum kita pergi lebih detail kepada stress and strain response, I think that the stress and strain response is quite familiar in the civil engineering. I mean that if you remembered kalau you ambil material, construction material ke, kemudian you ambil reinforced concrete designs, all that we talk about how the structure responds when subjected to loading. So these are the things that you have to understand and to differentiate how the material will behave for different kinds of the properties such as concrete. Macam mana dia react kalau kata dikenakan beban. And then when we talk about rock ni pula kita ada hard rock, kita ada soft rock. And also to the soil, ada soil yang normal consolidated clay for example. Ada soil yang over consolidated clay. And then ada pula sand yang jenis dense. Ada yang jenis what we call it dense dan satu lagi loose. So macam mana kita nak tengok dalam particular subject for soil mechanic ni, how clay and soil, kalau kita how clay and sand for two major groups ni bertindak ataupun react once it is subjected to a loading lah. Sama ada low loading ataupun high loading. But before that, you need to understand about the geotechnical engineering. These are the course outcome. So first of all is to evaluate geotechnical problems using principle of soil mechanics. Develop solutions for geotechnical problems that meet specified needs. Perform calculations and numerical analysis on geotechnical problems. Kalau you tengok setiap PO2, PO3, PO12 ni dia akan berada pada certain assessment yang kita dah design assign. For example, common test, PO2, PO3 contohnya. Project dia akan ambil PO3 dan juga PO12. So we may see that bila you look at to your PO attainment, individual PO attainment, you akan nampak either you are reaching to the 50% or less than 50%. Yang saya bagi tahu ni adalah sebahagian daripada OBE lah. OBE punya assessment apa yang OBE monitor dan juga measured. Okay, these are our role as a geotechnical engineer. When you go to somewhere ataupun you have went through your internship, kebanyakan awak ataupun kebanyakan pelajar may go to the consultant ataupun contractor, ataupun you may go to the public authorities department, and then you may see that some government agency, for example, they have different role in order to have what we call it their respective roles. Sama ada structural engineer ataupun geotechnical engineer. So what is actually geotechnical engineer deals in our civil engineering infrastructures, for example. Biasanya geotechnical engineer ni dia akan relate dengan design. Kalau sebut engineer dia mesti design. Kemudian dia akan buat analisis kan, sama ada analisis tu menggunakan tool ataupun manual calculations. And then engineers also need to do construction supervisions and monitoring. Tapi sekarang ni, because we have advanced technology, for example IoT, so kita dah boleh menggunakan satu application teknologi dalam monitoring dan juga supervision. For example, building information model BIM. So yang tu antara benda yang lebih baik lah, bagus lah berbanding conventional punya supervision dan juga monitoring. And then do geotechnical investigations. So geotechnical investigation ni, kalau you remember in the early topic, in the early course soil mechanics, we may start off with the site investigations. So apa pentingnya site investigation? It's a preliminary data before you can do your design and analysis and further to the constructions. Without the site investigation data, you may have or you may possibility having a wrong results ataupun a wrong preliminary input data for your future development ataupun for your design and analysis. So it's very important lah to do a investigations work. And then rather than that, you need to have a soil testing. So ada kita engineer yang tak bekerja dekat site ataupun dia tak bekerja dekat consultant firm, dia tak bekerja di contractor company. So dia bekerja di apa orang kata, company services that provide soil laboratory testing, for example, ataupun consultant ataupun service yang memang buat modeling and simulation. So ada juga engineer yang bekerja dengan supplier, jual equipment yang berkaitan dengan geotechnical engineering ataupun civil engineering. So they broad area untuk geotechnical engineer join after you are graduating. So don't limit your mind, okay, you nak work as a structural engineer. Sebab you nampak structural engineer, benda yang you selalu tengok dalam kita punya compositions of the courses pun banyak khusus yang terdiri daripada structural courses. But you have to look at from the minor important role as a geotechnical engineer, because any structure will start off dengan having a site investigation ataupun soil data. Without having the proper soil testing investigation that come from the geotechnical role, geotechnical engineer role, so there is no a high-rise building, for example. Itu yang saya nak highlight pentingnya seorang geotechnical engineer. These are some examples yang mana kita akan terlibat, contohnya soil testing, installations untuk pile, and then you are doing the deep excavations ataupun underground parking, ground improvement, slope stabilizations. Okay, apa beza geotechnical engineer dan juga structural engineer? Mostly on the as I said earlier lah kan, kalau structural engineer macam sekarang current trend is the health monitoring structure. Macam mana you nak buat rehabilitations of the structure, instead of you demolish old building kemudian you start over again and build a new structure. So daripada kita buat kerja macam tu, maybe ada setengah structure yang just perlukan what we call it here rehabilitations ataupun repairing work. So in order to here kita akan specify lebih kepada forensic investigations lah, lebih kurang macam tu kan. Maknanya structure pun dah buat, cutek pun dah main peranan dia. Kita nak tengok structure ni yang masa kita design in the early stage, which supposedly stand for 10 years, tiba-tiba tak cukup 10 tahun dia dah nampak crack sana, crack sini kan. So there's come structural engineer untuk buat inspection. Sama ada what are causes that having this problem. Adakah steel reinforcement dia dah mengalami corrosions ataupun the structure crack due to the settlement. So itu antara benda-benda yang you have to look in details before you doing any justifications or any repairing work. So perbezaan lah kan antara geotechnical engineer dan juga structural engineer. So kalau kata structural engineer, mostly dia akan deal with the concrete dan juga steel, kemudian geotechnical lebih kepada soils, And in order to explain the soil response, it means from the stress strain behavior or from the stress strain curve, you can see that the structural engineer always having material behave linearly. However, for soils, you may see that the stress strain behavior of the material of soil is a non-linear. It means that the soil more complex compared to the concrete and steel. It means also brings to you the meaning that what I said here is that the details investigation, very precautions, measurement in terms of the analysis and also the design. Okay, what are important aspects in geotechnical problems? For example, here we look at to the deformations and also the
Madam,
stability. Yes.
sorry.
Uh,
Tapi Madam gerakkan slide ke?
tak jadi
Dia tak gerak kat slide.
Nombor berapa?
Ni tak
Kan
pasti.
daripada awal.
The strength of materials.
Yang mana?
The strength of materials.
I think there's a problem lah yang mana dia mungkin tak boleh view as a large full screen view. Kalau yang ni nampak?
Still tak gerak lagi.
Still tak gerak. Let me check what's wrong.
Okay.
Kalau yang ni?
Sekarang kat geotechnical engineering. Okay.
Okay
Okay.
Alright.
Thank you,
Kalau
Madam.
saya besarkan, nampak?
Nampak, Madam?
Okay. So back to last I stopped the comparison between geotechnical and structural engineer. So don't worry about slides. I think that I will share later ataupun you can download from YouFuture. Okay, dalam geotechnical aspect, there are two things that you may need to consider. First is the deformations and the stability. On part of the deformations, talking about deformations ni, bila as I said, we play around with the soil characteristics, soil properties, and then how the soil responds under different loading, sama ada saturated ataupun unsaturated, atau dia dalam keadaan drain or fully drained. So these are the things that you need to have some kinds of the observations ataupun details analysis how it is deformed dan juga macam mana kita nak maintain dia punya stability. So it is very difficult and challenging topic in practice, and this need a very experienced engineer to predict ataupun to solve any problem regarding to the deformations. So talking about deformations as well, you can see kalau kita nak pergi ke the next topic, stress strain behavior ni, dia ada satu parameter yang kita panggil dia sebagai what we call it here is the strain. Strain adalah salah satu indicator how are you going to measure the deformations. The strain itself is the changes before and after to the original shape of the material selepas you kenakan beban. So daripada situ you can have the percentage of the deformations. Sama ada deformation the small deformations ataupun large deformations. And then there's some effect ataupun factors that control to the deformations. For example, the variability, complex stress strain relationship, elastic and plastic response. And similarly, when we talk about the strain, ada lagi satu parameter yang control kepada deformation which is known as a modulus. Later on, you may see few modulus that can be calculated or can be measured from the stress strain behavior. Okay, kalau kata softly, kita lebih closely look at from the consolidations ataupun from the settlement. And all those things can be observed or can be calculated or can be viewed in the 2 dimensions ataupun 3 dimensions. Some problem cannot be solved in 2 dimensions, yang mana kita perlukan 3 dimensions to look at overall the complexity. Sebab talking about the complexity, bila kita cerita pasal strain atau kita cerita pasal stress, dia punya komponen ada 6 komponen. 6 komponen kalau kita darabkan dengan matrix tu, dia ada beberapa lagi komponen yang menghasilkan stresses tersebut. So because you tak boleh assume soil is a rigid material, because bila I explain tadi comparison antara structural material dengan geotechnical material, yang mana soil ni lebih bersifat non-linear. So bila dia non-linear, dia bukan play as a rigidity structure. There ada some kind flexurality yang you have to look at how it is behave. Dia tak behave linearly, dia tak behave sebagai plastik saja, dia tak behave sebagai elastic. It sometimes can behave as a strain hardening, dia can behave as a strain softening. Dia bergantung kepada source you jenis apa. Kalau kata clay tu dia NC ke ataupun OC, over consolidated clay. Kemudian dia punya drainage tu sama ada drain conditions ataupun undrained conditions. And then when you talk about stress, are you looking stress in the total stress state ataupun you are looking at the effective stress state? So setiap yang I explained just now, that brings to you the behavior of the soil itself. That's why some of the complexity of the problem couldn't be solved in the 2 dimensions. They need to be solved in 3 dimensions. Okay, about the stability, so it is depending on the soil strength. So when I highlight as a soil strength dalam kepala you, you should familiar. The simplest one is the more column, for example. When you remember ataupun kalau you tak ingat lah kan, you just go back to your textbook, itu kan soil mechanic. Look at the common things about the strength. What is the strength? Is it strength ni only having one strength sahaja, ataupun they can have a peak strength, they can have residual strength, they can have the ultimate strength. Macam mana you want to identify all those strengths yang I mentioned just now from one curve only, from the stress strain behavior tu? Dekat mana yang kita panggil sebagai peak strength? Kat mana yang kita panggil sebagai ultimate strength? Kat mana yang kita panggil sebagai residual strength? Because all the strength yang I mentioned just now, they rely on the stress and strain behavior. Kalau kata your deformations occurred in the small displacement, kat situ kita boleh panggil dia apa? Ultimate strength ke? Ataupun kita boleh panggil dia sebagai peak strength ke? Ataupun dia adalah residual strength. Tapi kalau kata the strength occur in the large displacement after few years has taken place, so dia bukan lagi sebagai ultimate strength, dia mungkin boleh jadi residual strength. So just go back to your textbook, open up and then turn to few page, look at to the definition strength, and then what are the parameters control to the strength of the soil. So you akan nampak the comparison how it is behave for sand material ataupun for clay soil. Okay, antaranya collapse, loss of stability, then lastly is as I say, deformations. So next is on this one. Okay, kita pergi ke pertama, iaitu stress strain relationship dan juga stress path. Okay, yang ni nampak kan? Okay, untuk topik yang ni, tadi saya hanya explain pasal overview saja tau, overview apa yang kita akan cover dalam Advanced Geotechnical Engineering. So now is on the week 1, topic 1, iaitu stress strain relationship. So these are the learning outcomes from the first topic, iaitu able to evaluate the total stress path and effective stress path, and able to appraise more column model. Okay, untuk test one awak, more column model kita tak cover, yang kita hanya cover untuk yang for the first week lesson plan sehingga week 3. Kemudian more column ni kita akan KIV untuk final assessment, begitu juga dalam project tak silap saya. Dia akan ada sikit lah pasal more column. Okay, again this is on the how the soil response bila dia kenakan beban. Kemudian tadi kita tengok kan iaitu deformations, kemudian kita tengok stability, okay, masa bila yang dia boleh reach to the failure ataupun this structure having a collapse. So these are the things that you can see. Obviously kalau structure tu dah dah tumbang tu maknanya dia totally collapse dan strength dia memang low lah. Kemudian this is on about the apply loads are small ataupun the apply loads are large. So as I said again, yang ni pun saya dah mention just now talking about the small strain, large strain. Macam mana small strain dengan large strain ni ada kaitan dengan loading dan juga ada kaitan dengan stress. So biasanya bila you ada soil stresses that very low, then also they produce to you a small strain ataupun deformation is small. So of course there is no big problem. But then bila you kenakan large structure ataupun large loading, there is a chances to have a large deformation ataupun large displacement. So this is the time that you need to consider on the failure may occur. Okay, dalam geotechnical engineer, as I said, you have to check on the design, kemudian you kena buat supervision monitoring, and then you have to do some investigation to understand how the material it is behave. And it also depends on the two things. So the first one is the stiffness and also the strength. Okay, what is the stiffness? The stiffness of material defines how much deformations the material will undergo given the certain stress or more appreciably in soil ataupun the stress increment. Such as stiffness yang biasa yang you dengar adalah yang modulus ataupun shear modulus. Yang modulus ni is more easier lah because kita boleh nampak dia pada linear line yang mana you have a linear relationship. Tapi ada setengah material dia tak behave as a non-linear. So where it get the stiffness of the material, kat mana kita nak dapat material tu kan? Ada setengah tu it is represent dengan compression index CC. That's how we can say that the stiffness and also the strength of the material. So this is the concept yang mana you begin knowing about the Hooke's law. So yang ni pun saya just refresh balik lah kat mana daripada force ni. Dulu kita belajar dalam Hooke's law dia hanyalah melibatkan force dan juga elongations. Force ni you divide by certain area you akan dapat stress. So elongations ni daripada elongation you compare dengan original length dia ke apa kan, you akan dapat strain. From that dia akan produce to you one modulus ataupun one coefficient yang kita panggil dia sebagai modulus atau lebih specifically sebagai Young modulus. So Young modulus ni is a linear relationship between stress dan juga strain. Okay, ini adalah salah satu contoh the material behave under loading. So you can see that some of the curve, some of the stress strain behavior is not beginning with the straight line. Dia boleh mula dengan lengkung ataupun ada setengah material tu kita boleh nampak dengan jelas dia punya linear relationship dia. Somehow the material can show to you the ultimate point and then they can show you the maximum and also the critical point. So semua benda-benda tu yang you kena bezakan lah in order to explain the behavior of the material in terms of the stress strain relationship. Okay, yang ni just simple explanation to you. This is the point. Ada setengah buku panggil sebagai ultimate strength. Ada setengah buku dipanggil sebagai peak strength. Tapi kalau you tengok kepada textbook on the soil mechanics, on this peak ataupun maximum point on the curve, kita tak panggil lagi ultimate strength tau. Kita panggil dia adalah peak strength. Di mana berlakunya ultimate strength? Ultimate strength ni bila dia dah mengalami sedikit pengurangan in terms of the stresses or the loading, kemudian dia berubah lagi shape dia, that is the condition yang you akan nampak the ultimate strength. And then at one time bila you nampak the the stress and loading does not increase ataupun dia constant linearly pada satu keadaan di mana strain continue to deform ataupun to having a displacement, that is the time yang mana at the position at that point dia dah panggil residual strength. So dia dah tak sama lah antara peak strength, ultimate strength dan juga residual strength. So these are the examples of the stress strain behavior of the material. I said material tau, saya tak kata stress strain behavior untuk soil. So antara behavior yang you boleh nampak ataupun gambar represent the stress strain behavior, for example linear elastic. You know kenapa dia panggil linear elastic kan? Sebab dia adalah garis lurus hubungan antara stress dan juga strain. Kemudian ada juga non-linear elastic, ada juga elastoplastic. Elastoplastic yang mana the material behave elastic, kemudian they can behave as a plastic. So dia ada conditions, two conditions lah. And the material also can behave linear elastic, perfectly plastic. Contohnya kalau kata kita nak model soil behavior, atau elastoplastic strain hardening, or also elastoplastic strain softening. So berbeza pada dia punya straining point dia lah. Straining point kat sini you can see that the straining up go up maknanya dia makin lama dia harden. At another point kalau you mengalami straining tu makin lama makin menurun, so that is the condition dia mengalami softening point. Okay, ini adalah possibility relationship. Just to show you the difference between tangent modulus, initial modulus dan juga second modulus. So second modulus can be seen on the peak of the curve. Tangent modulus kita boleh nampak at this positions of the tangent, pada lengkung tangent tu lah. Pada lengkung kita ambil tangent dia, so kita akan dapat tangent modulus. Second modulus, if I'm not mistaken, also can consider dipanggil E50 lah kat situ, second modulus. Atau yang ni kita boleh check semula. Satu lagi dipanggil initial modulus. So dalam soil testing kita boleh dapatkan the stress strain behavior from one dimensional compression ataupun triaxial compressions. So triaxial compression ni benda yang biasa you buat triaxial testing lah. So these are the laboratory tests, for example untuk uniaxial compression and also the typical stress strain response. So this is applicable for rock and soil with significant cohesion. Okay, similarly at this part, so you akan nampaklah the difference between uniaxial compression dan juga triaxial compression. So dalam uniaxial compressions, you are only subjected the loading in axially. Itu kita panggil sebagai uniaxial compression. However, bila you are having we call it here as a triaxial compressions, so you akan ada axial stress ataupun axial loading, kemudian you akan ada compression stress. Dalam geotechnical engineering dia panggil sigma C is a confining stress. So this one we can have a similar as a major principal stress ataupun sigma 1. This also similar as a sigma 3 confining stress. Yang mana at this particular triaxial compressions, you akan nampak the axial stress is larger than the confining stress. Okay, one dimensional compressions, kenapa at this particular area, you remember bila you buat 1D test, kita confine dia punya deformation soil laterally. Maknanya soil tu tak boleh deform dalam keadaan horizontal. Yang mana soil can deform in vertically. Kat situ you akan nampak perubahan thickness daripada original thickness kepada final thickness. So when you have the difference from the final thickness to the original thickness, you akan nampak the settlement ataupun the vertical displacement. That's why in one dimensional compression test, you are having a boundary conditions laterally. There is no movement in horizontal ataupun in the x-axis, tapi you allow for any deformations in the vertical or in the y-axis. Okay, another then is that hydrostatic compressions. Kemudian kita ada juga simple shear. Yang ni example nak dapatkan modulus dan juga strength. Okay, ini adalah contoh-contoh lah modulus yang modulus. Kemudian kita ada bulk modulus, kita ada shear modulus. Shear modulus ni selalu bila dia melibatkan dynamic loading lah. And then dia melibatkan large ataupun small strain displacement. Okay, ini adalah refresh balik konsep untuk Poisson ratio, macam mana kita nak calculate Poisson ratio. Bila ada deformation, mesti ada Poisson ratio. Okay, ini adalah contoh typical value Poisson ratio untuk soil, concrete dan juga undrained soil. So you can see that the Poisson ratio for soil is the larger lah, 0.25 to 0.35. Kalau compared to the incompressible ataupun undrained soil, dia punya Poisson ratio is 0.5. Yang mana soil tu lebih large deform compared to the other material such as concrete ataupun moss soil yang lain. Ini adalah relationship how you may have the value of shear modulus, for example, ataupun bulk modulus K, ataupun you want to have the D. So by having or rearranging the equations, you akan dapat all this particular parameter. Example ni nanti you go through sendirilah because this is very straightforward calculation. You just substitute the value of the parameter to the formula. So you may have that one. So these are the typical values also. Young modulus for clay, silt, sand, and concrete and steel. So the strength of the material. So we're talking about the strength when it reaches to the fail condition, the failure of the conditions. Okay, yang ni pun the typical relationship stress dan juga strain, yang mana at this particular area you can have that it is linearly perfectly plastic. Kat sini dia dalam keadaan linear, kemudian kat sini dia dalam keadaan plastic. So this is the condition material to behave into two state lah. For the first one linear state, kemudian the second one is the plastic state. In the plastic state, there is no further increase in stress, and then you can see that at this particular sections or zone, the strain increase by the strain increase at the constant stress. Okay, then okay, untuk if you remember bila kita buat triaxial test kita ada limiting ataupun indication yang mana the soil has reached to the failure of deformations. So we set here at 20% strain. Ataupun kalau you remember when you record the data, kalau kata 2-3 data terakhir tu bacaan dia constant, so we can assume that the soil has failed due to the subjected loading you apply. Ini yang dia maksudkan 20% of the failure strain tu. Okay, that's end for today's lecture. Any question? Ada soalan tak? Okay, untuk yang minggu ni saya dah cover overview stress strain. So the next following weeks is a more tough sebab kita dah masuk kepada stress strain pass, yang mana kat situ you akan nampak macam mana tegasan berubah daripada total stress dan juga effective stress kalau dia ada some value of the pore pressure. So the stress state is a region ataupun satu plot yang menggambarkan laluan tegasan tanah apabila dia dikenakan beban. Okay, I hope that you are ready to the next topics. So I end this sessions for today. Any questions before we end?
Madam,
So for just now
tanya
yang
boleh?
aku tak nampak apa dia?
Nak tanya boleh?
Okay.
Ni macam lari sikit lah, madam. Tapi saya nak tanya, contoh kalau macam kan structure tu, dia runtuh kan? Dia sebab faktor utama dia soil structure tu lah yang ada masalah. Dia akan tunjuk crack-crack macam tu kan? Ada ke situasinya macam dia tak tunjuk pun crack atau settlement kat structure tu, tapi dia terus roboh? Lepas cek-cek dia punya masalah tu kat soil structure. Ada ke situasi macam tu?
Kalau on pavement you senang nampak. On pavement lah, talking about on pavement lah, contoh dia menyebabkan sudden downpour yang flooding kan, hujan tiba-tiba, tu senang you nampak settlement. Maknanya dia tak ada indikator pun, tak ada pun crack. Kalau you belajar pavement kan, pavement pun dia ada crack kan, dia ada retakan pada permukaan jalan kan. So dia bergantung pada situations yang mana faktor-faktor luar. Macam kalau pavement kita boleh nampak hujan panas, so sekejap dia mengembang, sekejap dia mengecut kan. So kalau untuk your question just now kan, untuk soil structure, when you talk about soil structure ni, dia tak sama dengan structure yang you nampak secara visible tu. Structure bangunan, sama ada high rise apa tu ataupun low building kan. Soil structure, when you talk about here, the soil structure arrangement in terms of dia closely packed ataupun dia loosely packed. So that is the meaning of the soil structure. So your question I assume macam ni lah, soil conditions lah. Soil conditions tu dia ada tak bagi sign untuk sign awal kita boleh nampak melalui crack ataupun tak ada sign tiba-tiba bangunan tu fail. In my opinion, for the beginning lah, untuk permulaan awal kan, you buat sebelum kita nak construct any building, we are doing the geotechnical investigation. Remember, kita akan investigate tanah tu jenis apa, adakah dalam tanah tu punya profile from the soil block, is there any cavity in the particular depth from the ground surface. So kalau kata there's a gap ataupun cavity dalam area tersebut, kita dah overcome in the early stage of the construction. For example, constructions of the KLCC in the area of the limestone. Remember, kalau you buka balik sejarah pembinaan Kuala Lumpur Tower tu, KLCC tu, bangunan KLCC ke ataupun KL Tower surrounding that area, in Kuala Lumpur mostly dia punya origins of the soil dan rock adalah jenis limestone. So bila limestone tu, you akan nampak di certain depth of the soil tu dia ada cavity, dia ada lubang-lubang, lompong. So bila ada this kind of cavity ni, kita dah treat, kita dah orang kata apa, kita dah buat stabilization, kita dah buat treatment soil, and then kita dah fill up this void of the cavity dengan some admixture, so that the soil structure in terms of just now tadi dia ada lompong-lompong kan, dia ada void tu dah ditutup. So in particular area, kalau you nak kata the soil fail in sudden due to the external factor, contohnya earthquake, yes, ataupun dia ada underground movement. Underground movement tu, that's why I said, kalau kata tanah tu dah dibina bangunan, kalau kita buat detail investigations, you can overcome dengan sudden collapse tu tanpa faktor luar, contohnya earthquake. Tapi kalau kata you dah buat detail investigations, kemudian dia tak ada pun sign of crack on the structure, tiba-tiba dia collapse tu, dia sama ada reasons juga, mesti ada faktor yang control dia. Maknanya air dalam tanah ataupun the building nearest to the slope, itu antara punca-punca lah yang bangunan tu boleh jatuh tiba-tiba tanpa menunjukkan sebarang early sign indications. Okay, Fatia?
Okay, faham madam.
That's why I said it's very important for the first one, you buat soil investigation. It may consume time and cost, tapi itu adalah, orang kata apa selagi mana nama you tertera atas project plan, you dah sign, kemudian approved by public authority untuk bangunkan bangunan tersebut, selagi mana you hidup, selagi mana bangunan tu selamat, lagi itulah you kena doa bangunan tu selamat selama-lamanya, ataupun kalau nak jadi apa-apa biarlah lepas you mati. Maknanya responsibility kita ada lah. It's not easy role lah kan. Maknanya you sebagai structural engineer ke geotechnical engineer ke, once you already declared yourself as a professional certified IR tu, you dah turunkan job and sign tu, you kena careful lah sebelum menurunkan tanda tangan. That's why try to avoid any rasuah ke apa kan, supaya bila orang suap ni dengan rasuah, maknanya ada something wrong lah dengan projek tu. Projek tu mungkin contohnya dia melibatkan cost material yang expensive, tapi sebabkan dia nak save cost, dia cut to the lowest budget material. So kat situ in future there will be a problem. So nampaklah kan masalah-masalah. Selagi mana masalah tak melibatkan nyawa, adalah masalah berat tu, tapi taklah sabit nyawa lagi kan. Tapi kalau kata dengan rasuah tu menyebabkan nyawa, ada kehilangan nyawa, harta benda semua tu, nak menjawab tu lah susah kan. Tadi nak jawab dengan structure collapse, orang kata apa, kita ada lagi payung atas lah, PPT apa kan, maknanya kita boleh buat lagi rehabilitation, repairing work. Kalau dah melibatkan nyawa ni, mana-mana lah apa-apa benda accident ke apa kan melibatkan nyawa, memang bahayalah. So it's a big responsibility as a technical engineer ke structural engineer. Once you are professional and certified, untuk luluskan projek tu, you have to go through in details from the beginning of the initial stage, daripada buat site investigation, go through the bore log report, bore log results, and then doing the judgment on the design and analysis part, choosing the right foundations, sama ada nak pakai shallow ke, nak pakai deep foundations ke. Kemudian kalau kata deep foundations, to choose whether span pile ke, micro pile ke. So all those things, there's a few considerations factor need to be taken lah before you can have a final one. So that's why you are assisted by your senior engineer, your superior untuk bantu you buat keputusan. It's not dia orang kata apa, as a junior one, you can have this simply justifications, decisions tanpa ada pemantauan atasan lah. Itulah yang bolehlah saya kongsi, ataupun you boleh thinking of something that in future what you are planning kan. Because kalau kita tengok you ada satu semester depan last, kemudian you dah mula fikirkan projek apa ataupun you nak kerja kat mana. So some sharing lah I can share with you, because this topic orang tak nampak, student tak nampak. Kenapa? Because advanced technical engineering, ada tu takut kan dengan advanced technical engineering. Tapi if you ask your senior last semester or last 2 semester, I think that there's a chance that you can pass. Sama ada flying colours or not flying colours, it's up to you. How your efforts through to the 14 weeks untuk reach to the flying colours punya great result. That's I can share lah. Don't be afraid lah, because right now lah, bila you keluar nanti, it is a value added bila you ada something extra daripada orang lain. Maknanya you tahu guna software kan, let's say tambah pula dengan projek-projek final year, subjek-subjek yang lain kan. So dia membantulah. Okay. So I end our lecture today. I'll see you next week.
Okay, madam.
Okay. Assalamualaikum and good afternoon.
Waalaikumsalam. Thank you, madam.
Thank you, madam.